Hello, today I will demonstrate Team 15 solution for use case 1 for the HP AWS Bot-a-Thon. Our objective is to not only create a Lexbot that meets the requirements proposed in the use case, but to create a dynamic, highly customizable Lexbot generation suite to meet the needs of a constantly changing workplace. The Lexbot generation suite is kicked off by a simple configuration file. Here, I have an example. For those familiar with the Lex service, some parts of this file might be recognizable, such as the intents and sample utterances. A user will initiate a conversation by saying a sample utterance, and then will be prompted with the first prompt inside of the tree. The Lex configuration file is primarily made up of this tree-style map of conversation patterns that the Lexbot should follow in order to efficiently handle information requests and process user transactions. Now let's take a look at another configuration file. This configuration file we wrote to capture the specifications of the chatbot flowchart we were provided. We have a tiered list that contains branches of options that a user may follow in order to meet their specific need. You can see we have, useful links, and then this opens up like a series of options and so forth. Now, one of our goals was to make the Lexbot highly modular and extensible. In this, we created a powerful action handler that enables developers to specify complex behavior in order to meet their fulfillments. Right here, we have an example where we have an action that queries the DynamoDB table in order to give a user an up-to-date response on HP's COVID policies. Now, this is just a simple example where we're making a query to DynamoDB and just grabbing the message with this title. But what's awesome is this is extensible, so you can constantly add more features. Right now, we have support for REST APIs and just calling any other AWS service. But it can be programmed and additions can be made in order to meet whatever needs, whatever APIs or such that you need to use. So I will now onboard a configuration file through our front end. I'll select the file and click Upload. After waiting a few moments, we can see that our Lexbot was generated successfully. Now let's hop over into Lex and see that the bot was created successfully. We can see our chatbot here. A quick scroll through the prompts and we can see that it matches up with everything that was inside the configuration file. So what exactly happened here? The React front end uploaded this file that we specified inside of the input folder of this S3 bucket. What this did was trigger a AWS Lambda function. This Lambda function ingests configuration files and then produces a chatbot and its corresponding knowledge base and deletion instructions. It then imports this chat box into AWS Lex. And on Lex, we can see our bot here. This bot is built and it's ready for testing. Let's start off this conversation. I'll start by saying help, and Lexbot will prompt me. I'm going to ask for useful links. Then I want to learn about HP's response to COVID, and I want to learn about the employee travel restrictions. Now, if you remember from looking at the configuration file, this is going to query DynamoDB and give us something up to date. Now, that's perfect. Let's go again. This time, I want to learn about product and pricing questions. I want to ask price for a product. And here is a product ID that I have, although a product name would work equally well. And there we have the price.